This video is an introduction to transformations. To transform a shape or figure means to change it. In general, we can change size, location, and direction that a figure is facing. There are 4 different types of transformations: translation, rotation, dilation, and reflection. Before we discuss that, we need to understand the idea of congruence and orientation. Congruence refers to whether or not a figure has the same size and shape after a transformation. As you notice, the 2 triangles below, triangle ABC is translated to triangle A prime, B prime, C prime. The size and shape are preserved, so therefore they are congruent. Orientation refers to whether or not the figure is facing the same direction on the coordinate plane after a transformation. Again, let's look at the example above. As you can see, angle A and angle A prime are both facing in the same direction. So therefore, the orientation was preserved. However, in the example below, angle A and A prime are facing in opposite directions. So in this example, orientation was not preserved. However, I want you to understand that sometimes shapes can look like they are still facing in the same direction. However, the vertices have changed. A good example of this would be a rectangle. The first transformation I want to discuss is called a translation, otherwise known as a slide. Here we have Bumblebee, notated as B for obvious reasons. And I want you to understand at first, the original picture or shape that you are going to transform is considered a pre-image. So this is the pre-image of B before he has been translated. Now, for a translation can occur in one of 4 ways. You can translate to the right, to the left. You can also translate up or down. You do not translate diagonally. However, sometimes it can look as that is occurred. If I translate B to the right and up, then he looks like he's been translated diagonally. Now let's discuss a specific translation. I am going to translate the pre-image of B 1, 2, 3, 4, 5, 6, 7 units to the right. The pre-image is now referred to after the translation as an image. In addition to that, the B becomes now what is known as B prime. It's notated as B prime to indicate the fact that it is the image and not the original pre-image. So now let's discuss congruence and orientation. Did B maintain congruence? Does he have the same size and shape? Yes, he does. So therefore, congruence was preserved. Does he preserve orientation? Well, he's facing to the left in the pre-image and continuing to face to the left in the image. So yes, orientation was preserved. The next transformation we're going to discuss is called a reflection, otherwise known as a flip. In this situation, we're going to look at Optimus Prime. Here's his pre-image. He's notated as O. Now, a reflection can occur over the y-axis or over the x-axis. To reflect Optimus over the y-axis, here he is. The image is now notated as O prime. And let's talk about some of the specifics. Well, this corner right here, I want you to notice what the reflection did. How did it change? So in this situation, you can see that this corner is 1, 2, 3 units from the y-axis. And on the other side, it maintains 1, 2, 3 units from the y-axis as well. It's equidistant on both sides. It's very obvious if you look at the sticker on Optimus's right shoulder, we can see that it's 1, 2, 3, 4, 5, 6, 7 units to the y-axis and equidistant on the opposite side. 1, 2, 3, 4, 5, 6, 7 units over the y-axis. You can also reflect Optimus over the x-axis. And here's what that looks like. So from the pre-image to the image, again, notated as O prime. And looking at how these get affected, again, it is 1 unit and equidistant on the opposite side of 1 unit. And that occurs from the sticker as well. So now let's discuss, does Optimus preserve congruence and orientation? I'm going to reflect him over the Y so you can see that congruence is preserved because he does maintain the same size and shape. However, does he preserve orientation? Well, in the pre-image, Optimus is looking to the right, but in the reflected image, Optimus is now looking towards the left. So therefore, no, the orientation was not preserved. Our next transformation is called a rotation, otherwise known as a turn. A turn or rotation can occur one of two ways: clockwise, going the way a hand turns on a clock, or counterclockwise, the opposite direction. For a transformation, when we're dealing with rotations, counterclockwise is the one that is understood, unless it is told to you. So if it's not told which direction you are turning, you understand that it is counterclockwise. Here we have Grimlock, and I am going to rotate him counterclockwise along the circle of the coordinate plane. Now, as you can see the degrees of the circle, so here we are going to rotate him 90 degrees, 180 degrees, 270 degrees, and back to 0, otherwise known as 360 degrees. We can also rotate Grimlock in the clockwise direction. That's looking at the red numbers. So here we're going to rotate him clockwise 90 degrees, 180 degrees, 270 degrees, and back to 0. Now, from his pre-image, say he was rotated to this new image, it can be referred to one of two ways. Grimlock was rotated counterclockwise 270 degrees or clockwise 90 degrees. Now let's discuss congruence and orientation. Did Grimlock preserve congruence? Did he change size or shape? No, he did not. So therefore, yes, congruence is preserved. However, did he preserve orientation? Well, in the beginning, he was facing to the right, and now he's facing down. So therefore, no, he did not preserve orientation. The last transformation we're going to discuss is called a dilation. It's referred to as a stretch or a shrink. Here we have Sideswipe, and I am going to stretch him out and make him larger. And we can also shrink him to make him smaller. So from the pre-image to the new image, let's discuss, does Sideswipe preserve congruence? Well, in this situation, the size going from large to small, does it preserve congruence? No, it does not, because size did change. However, does Sideswipe preserve orientation? Well, when I shrink and stretch him, he's still facing to the left. So therefore, yes, he does preserve orientation. Here's a few more examples of real-world transformations. As you can see, a piece of luggage is being slid back and forth. This is an example of a translation. Here we have a wheel being rotated round and round, so a rotation. On this image, you can see the landscape is being reflected into the water. In our last image here is you can see the dilation of the eye that would occur at an eye doctor.